Okay, good morning students. So in the Cryptography and Network Security lecture series, the topic that we are going to discuss is about RSA. So it is one of the famous encryption algorithm which from the unit 3. So before that which was be handled by Logesswari from RMDEC college working as an assistant professor in CSE department. So let's move on to the session like what is RSA. Actually RSA is subdivided as Ron Reversed, Al Ashamir and Lent Handelman at MIT in 1977. Actually, it is a public key cryptographic algorithm. We earlier, in the first unit itself, in first and second unit itself, we discussed like what are the different encryption algorithms are there. So likewise, it is a very famous algorithm. So it's a block cipher algorithm in which plain text and ciphertext are integers, and then a typical size of 1024 bits or 3 decimal digits. Integer factorization. So how we have to compute the RSA algorithm just step by step. It is a one-way trapdoor function. We can't able to return the message. It is infeasible. First we have to compute 2 primes as easier. So n is equal to p into q, and then you have to find out the decryption constant d. So which is given as we have to find out e, n, p and q. We already know about e. We already know about n, p and q is easier, but computing d and then e comma n is infeasible because the factoring of n is difficult. So we have to find out and then we are trying to find out this algorithm. So this is the algorithm for ciphertext. C is equal to m power e mod n and m is equal to m power d c power d mod n. Okay, so both the sender and the receiver must know the value of n. Sender knows the value of e and only receiver knows the value of d. So public key, this way we have to find out public key pu is equal to e comma n and pr is equal to d comma n. And then the algorithm should satisfy, it is possible to find the values m power edn is equal to, and then it is relatively easy to calculate m power e mod n and c power d mod n for all the values. So this is the algorithm working flow. We have to select it and then we have to find out n value and calculate pi of n is equal to p minus 1 and q minus 1. We have to select an integer e which should satisfy this condition, that is GCD of pi of n comma e should be 1, and then this e should be it should be of range between 1 to pi of n, and then we have to calculate d which is of multiplicative inverse of e minus 1 mod of pi of n. So in this way you have to find out public key and private key. So encryption algorithm is we can select any message which should be lesser than n. C is equal to m power e mod n. For the decryption we have ciphertext. We want to find out the m. If that m and c should be same now, so it is working fine. So m is equal to c power d mod n. So as you can see this example. I have taken p is equal to 13 and then q is equal to 11, e is equal to 7 and m is equal to 25. M stands for the message. And then first I am directly going for n computation. N is equal to p into q, that is 143, and then c is equal to m power e mod n. So 25 power 7 mod 143, c is equal to 64. So for the decryption process, c power d mod n, pi of n is equal to p minus 1 into q minus 1. So and then we tries to find out the d value e inverse mod n, 7 inverse mod 120 which is equal to 103, and 64 power 103 is 103 into 1 mod 143, so which is equal to 25. Here they have given how they are finding out the 64 power 103. So you can use calculation, you can use extended Euclidean algorithm to find out the inverse value, that is a multiplicative inverse value. Here you can use CRT is also to decrypt it. Okay, so same thing. Okay, fine. The attack. So these are about the RSA encryption algorithm, students. Thank you. I hope you have understood the concepts.